All right, 1.5 in Alex. We're going to be solving quadratic equations that could have complex roots. So you can solve these either by completing the square or using the quadratic formula. The only problem is completing the square is difficult if you have a leading coefficient. So I'm just going to stick with the quadratic formula because it always works even if there's a leading coefficient. Now, the quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. So wonderful. Okay. Now, the quadratic formula requires that your quadratic equation has all of the information on the same side of the equation and it's listed in descending order. So if you don't have that set up, you need to fix it so that you do, so that your A, B, and C are lined up properly. So for number 1, we are going to do negative 9 plus or minus the square root, and the mistakes that people make are usually inside the square root. So for the b squared, don't worry about signs. Don't say negative 7 squared. Just do 7 squared because it's going to turn itself positive. So that is a really common mistake, is putting a negative right here when it should be positive. So if this was negative 9x, don't worry about the negative when you square it. So 81, and then the other really common problem is messing up the negative 4ac. So what I like to do is write off to the side negative 4 times 4 times negative 1. And notice that negative came from inside. So negative 4 times 4 is negative 4 times negative 1 is plus 4, and then I write plus 4 in here. And that really is the most common mistake people make. They mess up this negative by not putting it inside the multiplication. Okay, all over 8. So we simplify what's inside that square root. Negative 9 plus or minus the square root of 85 over 8. And does 85 factor? Factors into 5 and, would that be 17? Oh, apparently I can't do math. How did I ever graduate college? How about 16? Thank you. So 81 and 16 makes 97. Oh, which also doesn't simplify. So negative 9 plus or minus the square root of 97 over 8. Okay. What if instead of 97 it was 48? And I factor that and I get 4 and 12, 2 and 2, 2 times 2 times 3. So you circle the pairs. For every pair you write 1 on the outside. So the outside would have 2 times 2 and the inside would have a 3. So you would get 4 root 3. But this one didn't simplify. Okay. Let's find one that actually does have complex roots. Yep, that was the answer. What would you do for number 2? Subtract 1 and then plug it into the formula. Okay. Oops. Oh, you like that? Ooh. Whoa. Zoomed in a little too far. Sure. Okay. All right, let's try this one. Yep, I think this will work. So, negative 5, well, I gotta push the pen. Negative 5 plus or minus the square root of 25, and then negative 4 times 4 times 2, that's 32, over 8. So 25 minus 32 is negative 7. Okay. Does the square root of negative 7 simplify? The only thing that can come out is an I. So we put the I right there. And the answer is negative 5 plus or minus I root 7 over 8. Yeah, you just leave it like that. It doesn't simplify. What if I ended up with 12 plus or minus 16I root, let's say root 6 over 8? Well, so the stuff inside the square root cannot simplify, but these three coefficients all have a common factor. They all have a 4. So I can pull a 4 out of everything, and I get 3 plus or minus 4I root 6 over 2. But notice, those did not simplify, because that's really not a 6. It's the square root of 6, which is like 2.4 or something like that. Okay? So when you simplify quadratic formula fractions, if all three parts have the same factor, then you can remove it. But one of those parts is not the square root. Okay, you can pull stuff out of a square root, but you can't divide factors inside a square root. Okay, let's do a model rocket is launched with an initial upward velocity of 195 feet per second. The rocket's height h in feet after t seconds is given by the following. Find all values for t, which the rocket's height is 87 feet. So it says this equation works, and we want to know when is the rocket higher than 87 feet. So we put 87 right there. And you could move everything to the right. I'm going to move it to the left. Why would I move it to the left? I want my leading coefficient to be positive. So that gives me 16t squared minus 195t plus 87. And I'm going to put that in the formula. Let's say when I'm done, I end up with something like 4 plus or minus 2 root, let's do 14, plus or minus 2 root 3 over, drop my marker, it's not good, over 2. Okay. Well, that number is not very useful, right? It's not a very practical number. So what should I do to it to make it more practical? Well, it doesn't simplify any further. I can't go any further, but there is something I could do to make it a more usable number. We need the decimal, right? Let's just plug it into our calculator. Is my calculator here? Oops. Nope, it's on my other screen. So don't forget that the numerator is, you need to treat it like it is a fraction. So I'm going to do 14 plus 2 root 3, enter, and then divide it by 2. And I get, what does it say, nearest hundredth? So 8.73 seconds. And then, yeah, I figured that wouldn't work. And then 14 minus 2 times the square root of 3. And divide that by 2. And I get 5.27 seconds. So the question asks, find all values of t. Oops. What am I doing? Find all values of t for which the rocket's height is 87 feet. So the answer is 8.73 seconds and 5.27 seconds. So the rocket goes up and then comes down, and at some point it's 87 feet high. And that occurs at 5.27 and 8.73. That makes sense? So in the practical world, decimals make way more sense, right? We can look at a decimal and figure out how big it is. In the mathematical theoretical world, this number is a lot easier to use. So we call these approximations, and we call these exact answers. And mathematically, we like exact answers. They're not as messy. They don't have decimals that go on forever. Well, they do. You just can't see them. So you need to know how to go back and forth between the two. All right? If it asks you for a decimal, give the decimal. If it asks you for the exact answer, then you got to build that fraction. Okay, I think... What's that? Yes. Well, let's double check. I believe so. Yep. Okay, get to work.